You would never imagine, even in your wildest dreams, that this is how Earth was born. 4.6 billion years ago, on the edge of the Orion arm of the Milky Way, a star was born. Dense gas and dust collapsed toward its center, forming a vast rotating disk around it. That seemingly ordinary star would become our Sun, and the swirling disk of material around it would eventually evolve into our solar system. Inside this protoplanetary disk were countless mineral particles. Through constant collisions and gradual sticking, these tiny grains began clumping together. Small rocks became larger rocks. Larger rocks became massive chunks of matter. As these bodies grew, gravity took control. Bigger planetesimals attracted smaller ones, forming clusters of rock. Over time, these clusters collapsed inward. Through a process known as accretion, planetary embryos were born. One of them would become Earth. But about 4.5 billion years ago, a Mars-sized planetary body named Theia collided with the young Earth. The impact was catastrophic. The collision released unimaginable energy. Earth's surface melted into a global ocean of magma, a world of fire. Earth survived, Theia did not. The debris from Theia mixed with Earth's material and began orbiting the planet, forming a ring of molten fragments. Over time, gravity pulled these fragments together. A new celestial body was born. The Moon. When it first formed, the Moon was nearly 16 times closer to Earth than it is today. For the next 1.5 billion years, it remained geologically active. Meanwhile, Earth slowly began to cool. Its surface hardened. The early atmosphere formed from gases released from deep within the planet: ammonia, methane, nitrogen, hydrogen, and water vapor. This was not a habitable world. Thick, high-pressure toxic gases blanketed a scorching volcanic landscape. This was Earth's first geological era, the Hadean, the darkest and most chaotic chapter in Earth's history. The Hadean Eon lasted from 4.6 to 4.1 billion years ago. About a year after the Theia impact, the violent energy began to settle. Earth entered a long and difficult cooling process. As temperatures slowly dropped, something extraordinary happened. Water vapor in the atmosphere began to condense. The first white clouds appeared in the sky. These clouds increased Earth's reflectivity, bouncing large amounts of solar radiation back into space. Cooling accelerated. Although surface temperatures were still far above 100 degrees Celsius, the thick, high-pressure atmosphere prevented water from boiling away. Clouds thickened, moisture accumulated. Then the first rain began. Not a normal rainfall. A planetary storm that lasted thousands of years. Countless drops of water fell like silver arrows onto the burning surface, reacting violently with hot rock and rising again as clouds of steam. Over time, rainwater pooled, basins filled, the first lakes and oceans formed. Eventually, nearly the entire surface of Earth was covered by water, transforming into a mysterious ocean world shrouded in methane haze. Around 4 billion years ago, after hundreds of millions of years of violent instability, Earth began to stabilize. The Hadean came to an end. A new era began, the Archean. The Archean Eon lasted from 4 billion to 2.5 billion years ago. Volcanoes were still active, landmasses had formed, oceans existed, rain fell. But there was no oxygen in the atmosphere. The sun was about 25% dimmer than today, yet lethal ultraviolet radiation bombarded the surface. Without oxygen, there was no protective ozone layer. And yet, life had already begun. In Earth's oceans and soils lived primitive single-celled microorganisms, prokaryotes. Their cellular structure was simple. No nucleus, no complex organelles, yet they were fully independent forms of life. They consumed chemical substances for energy. They metabolized. They reproduced. They evolved. Scientists believe that early single-stranded RNA molecules once carried genetic information and could replicate themselves. But RNA was unstable. Eventually, a more stable double-stranded molecule appeared, DNA. DNA became the reliable storage of genetic information, while RNA helped translate and replicate that information into proteins. Together, they formed the foundation of all life. These ancient microbes thrived in extreme environments, feeding on chemical nutrients and quietly writing the first chapter of biological evolution. Then came the Proterozoic Eon. From 2.5 billion to 540 million years ago, nearly half of Earth's history. Cyanobacteria began to rise. These tiny organisms consumed carbon dioxide and, through photosynthesis, released oxygen into the atmosphere. Over hundreds of millions of years, this oxygen revolution triggered the Great Oxidation Event. Atmospheric oxygen levels surged, greenhouse gases like carbon dioxide and methane were drastically reduced. Earth lost its insulating blanket. Temperatures plummeted. Polar ice sheets expanded, spreading toward lower latitudes like massive white serpents. As ice coverage reached a critical point, a deadly feedback loop was triggered. Bright ice reflected more sunlight into space, causing even further cooling. Eventually, even equatorial oceans froze. Earth became a global snowball. This extreme ice age lasted nearly 300 million years. And yet, beneath the frozen surface, life endured. Near hydrothermal vents on the ocean floor, thermophilic microorganisms survived in mineral-rich boiling waters, preserving the spark of life. Volcanic activity intensified. Tectonic forces tore through Earth's crust. Massive eruptions released carbon dioxide back into the atmosphere. But the final break in the icy stalemate came from above. A massive asteroid struck Earth with immense force. The impact released enormous energy, melting ice and injecting greenhouse gases into the atmosphere. A warming blanket formed. Earth awakened from its frozen prison. Near the end of the Proterozoic, life made a dramatic leap. Single-celled organisms evolved into multicellular life forms, setting the stage for the Cambrian explosion. Then came the Phanerozoic Eon, beginning about 570 million years ago and continuing to the present. This is the era of visible life. It is divided into three major eras: the Paleozoic, the Mesozoic, and the Cenozoic. The Cambrian explosion marked a miracle in Earth's history. Algae, sponges, corals, and countless new life forms flourished. Early fish, amphibians, and reptiles emerged. Most modern biological lineages trace their origins to this time. The Mesozoic became the golden age of dinosaurs. From the Triassic rise 230 million years ago to their extinction 65 million years ago. Dinosaurs ruled terrestrial ecosystems for 160 million years. Gymnosperms like conifers and ginkgo trees dominated the landscape. Then came the Cenozoic, the age of mammals and flowering plants. Mammals diversified rapidly, primates evolved, and eventually, intelligent humans appeared. Humanity would fundamentally reshape Earth's ecosystems and civilization itself. Meanwhile, the planet's surface never stopped changing. Since the Cambrian, tectonic plates have remained active. The supercontinent Rodinia broke apart. Later, Pangaea formed and then split again, giving rise to today's 7 continents and 4 oceans. Volcanic eruptions, advancing and retreating glaciers, rising and falling seas. The Phanerozoic carries the intertwined story of life and geology, a window into Earth's past and the origin of everything we know. From molten chaos to conscious beings. A journey of 4.6 billion years. And we are living in the latest frame of that story. During the Cenozoic era, mammals did more than simply survive, they expanded into nearly every environment on Earth. Some returned to the oceans and evolved into whales. Others adapted to open grasslands, becoming large herbivores and swift predators. Forests became home to increasingly intelligent primates. Over millions of years, certain primates developed greater dexterity, binocular vision, and larger brains. In Africa, one lineage began to walk upright. Hands were freed for tools. Social structures became more complex. From early hominins to Homo sapiens, evolution accelerated in ways unseen before. Humans spread across continents, adapting to deserts, forests, tundra, and mountains. They learned to control fire, cultivate crops, build cities, and reshape landscapes. In geological time, this transformation happened almost instantly. While tectonic plates continued their slow drift and glaciers advanced and retreated, human civilization rose in just a fraction of a second on Earth's vast timeline. Forests became farmland, rivers were redirected, species disappeared, technology reshaped the surface of the planet. Yet beneath it all, the deeper forces of Earth remain unchanged, continents still move, oceans still circulate, and evolution continues.